Our last look at limits, we were looking at tables and graphs. So today we're going to extend on that idea. So right here, I've got a couple limits that we're going to look at. This first limit is the limit as x approaches 2 of x plus 3. So I've built my table using as x gets closer and closer to 2, what is my y value approaching? And in this case, my y value is approaching 5. Okay, we can see that from our table. On my second example, I have the limit as x approaches negative 1 of x cubed plus 1 over x plus 1. Again, I've already got my table. As x gets closer and closer to negative 1, what is y getting closer and closer to? And in this case, we can see as x gets closer to negative 1, y is getting closer to 3. Okay. This table idea is to help us visualize what's happening with our limits, but it is a little bit time consuming if we're not using our calculator to build our table. And if we don't have a calculator, how do we build our table? So there are a couple different ways that we can evaluate a limit. Let's go ahead and take a look at my first example and see if we can see that. Okay? So if my limit equals 5, if I come and I look at my original problem, is there a quick way to see the limit equaling 5? Well, the limit as x approaches 2 of x plus 3, what happens if I just substitute that 2 in here? Well, 2 plus 3, it equals 5. The limit equals 5, and I can see that just by substituting the 2 in. That works because x plus 3 is a linear function. It has no discontinuities, no asymptotes, so simply plugging in 2 is going to tell me my limit value. Okay? Our y value is equal to our limit in that example. By plugging in 2, I'm able to evaluate my limit. If I use that same approach on my second example, if I just simply plug in my negative 1 into my x's, I'm going to get negative 1 cubed plus 1 over negative 1 plus 1. Negative 1 cubed is negative 1 plus 1 is 0. Negative 1 plus 1 is 0. So in that case, when I plug in my negative 1, 0 over 0, we got a problem, okay? This is an indeterminate form. I've got to do more work to solve this one. But if we substitute in our c value in our limit, if we substitute it in and we get out a y value, that is our limit. So our first approach to solve algebraically is to simply plug in that c value. You plug in the c value, and if you get out a number, perfect, you're set. That is your answer. Work done. But if we end up with a 0 over 0 case, we've got to do more work. So tune in for our next video to figure out what happens if we get an indeterminate form.